Alright, this is 10.6 in Advanced Algebra 2. Today, Law of Cosines. The Law of Cosines, this is really what it says right here. Any triangle you can do it with. You don't have to have a right triangle. You know, it works on right triangles, but it says all of this stuff right here where A, B, and C. Remember, big A is your vertex, little a is the side across from it, and etc. I always just kind of simplify it to be this, you know. I call it x squared equals b squared plus c squared minus 2bc times the cosine of big X. If you jot that down on your paper right there, I like it because X is usually like what you're looking for, and you kind of get confused in these other three. It's like, well, which one am I even looking for here, you know, because they might not use the vertices A, B, and C. So little x, though, you got to realize is the side length, right? Because all side lengths are lowercase letters, and I make that a big X right there because that's like the angle measure. So the time that you use the law of cosines is when you are given like more than one side in your triangle. As you can see in this triangle right here, they give you a side length and another side length, more than one side length with an angle measure. Really works with the side angle side. As you can see, you've got a side, then an angle, then a side, or a side, side, side. Um, it doesn't really work. It's called the ambiguous case when you do angle, side, side, you know, and we kind of learned in geometry that that was a bad deal. But those are possible to solve. But true law of cosines is side, angle, side, or side, side, side. I just do this. They call it cosines because you have more than one side. It's like cosines, cosides, right here. So consider the angle, the triangle at the right. Find little c, round to the nearest tenth. Well, they want me to find this little c. This is what I don't know. It's a side length, so that's basically this in this problem. Little c squared will equal. B and c are the two other side lengths, so it doesn't matter which one's which. 15 squared plus 28 squared minus 2 times b times c, where remember b and c are just those two side lengths. Was it 28? And then times the cosine of the angle measure, that's across from the side you're looking for, which is 82. What I want us to do before we just punch all this in our calculator is clean it up a little bit. Let's figure out what this is right here, this 15 squared plus 28 squared. So I'll just punch that in, 15 squared plus 28 squared, and that's 1,009 minus 2 times 15 times 8, 28, 2 times 15 times 28. So just kind of making this look a little prettier for myself. 840 cosines of 82. And here's the thing you've got to understand about this lesson today, is there is some multiplication going on right here between this number and the cosine of 82. You cannot subtract these numbers of the 1,009 and the 840 because the order of operations would get violated due to this multiplication step right here. So just write it down like this. That's what c squared is, so let's punch that in. It is 1,009, my bad, 1,009, well that's not going to work. There we go. 1,009 minus 840 cosines of 82. Again, making sure your calculator's in degree mode. And you get that. So I'll just jot that down. That c squared is about 892.0945, blah, 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 blah. Realize I'm not rounding that guy off because that's what c squared is. What I need to do is square root that answer, and that's what c is approximately. So they tell me to round to the nearest tenth, so I'll do that. It's about 29.9. And this should be review for you because you should have done this last year. So points S and T are the endpoints of a tunnel through a mountain. So you got this awesome looking mountain. We've got a top view of the mountain here. From point Q away from the mountain, it is possible for a surveyor to see both points S and T. So you got a surveyor standing here, and he looks this way, looks that way. The surveyor finds that the distance from Q to S is 720, and distance from Q to T is 510, and the measure of angle SQT is 84.5 degrees. Find the length of the tunnel to the nearest meter. So here's your tunnel right here, x. It's a side length, so that's little x squared Law of cosines, because we've got this triangle right here, and we know two sides and an angle measure, and it's not a right triangle, so that's why we'll use law of cosines. So x squared equals 510 squared plus 720 squared minus 2 times those same two numbers that we just squared times the cosine of the angle measure, which is 84.5. Then we'll just clean it up just a little bit. So 510 squared plus 720 squared, kapow, big number, x squared equals 778, comma 500 minus 2 times 510 times 720, kapow, 734 400 cosines of 84.5, and then I'll just punch that in my calculator. That's 778,500 minus, I got that number stored as my previous answer, times the cosine of 84.5. That's what x squared equals. So x squared is about 708, comma 110.8793, blah 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 blah, and I need to square root that number. Come on. X is about 841 meters, because they asked me to find the length of the tunnel to the nearest meter. Next guy, find the measure of the smallest angle in triangle ABC if the distance from A to C is 8, distance from B to C is 10, and distance from A to B is 12. Round to the nearest tenth. Draw a triangle, label its sides, and then let's see what we got. So we'll draw ourselves a triangle here. Just take a straight edge or your geometer. It's a scalene triangle because all three sides are different, and make sure you get the right side lengths in there. Distance from A to C is 8, distance from B to C is 10, my bad. Distance from A to B is 12. Find the measure of the smallest angle. Well, the smallest angle is always across from the smallest side. So, since 8 is the smallest side, this is the smallest angle. You can call him big B, you can call him big X, you could put theta in there. It really doesn't matter what we do here. Right? So, we can just realize that's what we want. This is a side-side-side situation. We've got more than one side, cosides, right? So this is a law of cosines problem, to where the side across from the angle is always that little x. So you start with 8 squared, and that'll equal the other two sides, 10 squared plus 12 squared minus 2 times 10 times 12 times the cosine of your theta, or your capital B, or your big X, whatever you called it right there. But realize that the 8 had to go here because he's the side across from your angle measure. That's what that was all about. They have to be the sides across from each other. Big X and little x are always across from each other. So we got this. This is 64 equals 10 squared plus 12 squared. Scroll him up a little bit. 10 squared plus 12 squared. I have it figured out before I punch it in. It's 244 minus 2 times 10 times 12, which is a negative 240 cosines of theta. And now, different scenario here. We are trying to basically get cosine of theta all by himself right here. You can't get theta all by itself without doing the inverse cosine, so you just want to get cosine of theta all by itself right here. So what I need to do is get rid of this 244 first, so I will subtract 244 from both sides. So 64 minus 244 is a negative 180, and that will equal a negative 240 cosines of theta. And now I'll divide both sides by negative 240, so negative 180 divided by negative 240 decimal, math interim, or realize that that's 3/4 equals the cosine of theta. And now you do the inverse cosine. So theta equals the inverse cosine of 3/4. And we'll punch that in. The inverse cosine of 3/4. What do they want us to round to? Round to the nearest tenth. Reading is fun. Theta is about 41.4 degrees. So that would be the measure of the smallest angle in that triangle, because he's across on the smallest side. And the next one, on the back side, we got to draw a picture of that again also. So I'll let you pause the video and get that done. Then it says find the measure of the largest angle to the nearest degree. The largest angle is across on the largest side. It doesn't matter how your picture looks. You know, your picture could be kind of all out of proportion and all that stuff. But if 8.5 is the largest side, then the largest angle is across from him. So I'll put myself a theta there. And now I will use the law of cosines, because this is not a right triangle. We don't know that. I mean, we could prove that it's not, because 4 squared plus 5 squared does not equal 8.5 squared. But since we have more than one side, we'll use the law of cosines. The side across from the angle goes all by himself. The other brothers, how about a 5, please? Go now. Minus 2 times 4 times 5 times the cosine of theta. Clean it up. 8.5 squared. Chapow. 72.25 equals chapow. 4 squared plus 5 squared. 16 plus 25. Be 41. Minus, that's 8. And 8 times 5 is 40. Cosines of theta. Do not forget, you cannot subtract those. I forgot to mention that on the previous problem. You cannot subtract these numbers from each other due to the fact that there is multiplication right here. This does not just turn into 1 cosine of theta, because you can't do the subtracting part when there's multiplication right here. So we need to subtract the 41 over from this side. And let's see, 72.25 minus 41. You can punch that in. That'll equal negative 40 cosines of theta. And then I will divide in my spalculator. I want 31.25 divided by negative 40. I get that decimal. I'm going to math enter in. And it's negative 25/32. Scroll it. Equals the cosine of theta. And then I will now inverse cosine. People might be scared because that's a negative number. Interesting. Second inverse cosine of negative 25 divided by 32. Close it. Well, isn't that just fabulous? That theta is about 141 to the nearest degree, degrees. Sweet. Find the missing part of each triangle using the law of cosines. Round the irrational solutions to the nearest tenth. So, law of cosines again, because we have more than one side. It's a side angle side situation. We're looking for the distance from B to C. I'll just call him x right here. And remember, that's the side length, so we'll do little x squared equals 9 squared plus 16 squared minus the deuce times the 9 times the 16 times the cosine of 80. And then I will let you punch that in and see what you get. Pause the video, try that one for me. So if you clean that up a little bit, you should have got the 337 here and the negative 288 here. Then we just punched that in our calculator, and it turned out that x squared was about 286.989, blah, 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 blah. You got to square root that number, and x is about 16.9. So about 16.9. Find the distance from T to A. Pause the video, see if you can set this up with the law of cosines correctly. Then check back to see if you set it up right. This is the side we're looking for. It's across from that 120, so that's little x. And here's the other two sides squared, minus 2 times those same two sides, times the cosine of 120 in that situation. And then to punch all this in, we'll punch all this junk first. We'll clean it up a little bit though, and I'll clean it up to be 949 minus 900 cosines of 120. And then this came out to be like 1399 perfectly, which is interesting, 120 must be a special number. And then you square root that, and x is about 37.4. Since they said round to the nearest tenth, we'll put about 37.4. So, sweet. Find the measure of angle K. I'll put a theta in that bad boy, and this is a side-side-side situation, still law of cosines. Get her set up, solve for theta. Pause video, check back when you're done. And here's what she should have looked like. Should have got measure that to be about 67.4 because they said round to the nearest 10. So I used a big X instead of a theta. Same thing, right? Big X, theta, big K, whatever. But you got to realize again, you cannot subtract these two numbers. You need to subtract the 365 over because there's multiplication going on here. And then just math enter that number and get that 5/13. Finally, find the measure of the smallest angle. The smallest angle is, of course, across from the smallest side, so that's our theta right here, or a big X, or a big O, whatever it is. So I will set it up as the side across from the angle that I'm looking for, 336 squared, equals the other two brothers squared. And these are going to be some larges numbers when we deal with them. Minus 2 times 511 times 385 cosines of theta, or big X, or whatever you have. And now we'll clean things up. We'll punch this stuff in, so I'll let you do that. Pause the video to get that done if necessary. And like I said, they're going to be very large numbers. Then we need to subtract him over. And when you subtract him over, you get this big old honker negative. And finally, this stuff comes down. Divide this big old honker negative by that even larger honker of a negative. Then math enter him, and you'll get 55/73 equals the cosine of big X. And then you do the inverse cosine and round yourself to the nearest tenth. The old law of cosines. When to use it? When you don't have a right triangle and you have more than one side length. Cosides, cosines. Let me know if you have any questions. Have a good one.